Hello, everyone, and good afternoon, good morning, depending on where you are. Happy to see everyone. I hope that wherever you're located, you're doing well. And I'm going to adjust this camera a little bit so that you can see me. I think it's better. Maybe it's even too much. I actually probably want to adjust the frame of this camera eventually, because right now it's making me look a bit too small on the side, but we'll see. Anyway, today's project is to standardize what is called the event log in CockroachDB. What the event log is a facility that was built extremely early. It's one of the oldest mechanisms in CockroachDB to report important events in the life cycle of a CockroachDB cluster. What would be an important event? A node starting up, a node joining the cluster, a node restarting would be important events. But this facility is also able to report important SQL events, like the creation of a table, or dropping a table, or creating a database, and adjusting schemas, or this kind of things, and including changing privileges on objects. What it does not do yet, but could be doing, is also adding events for backups and restores. We haven't done that yet, but this facility could be extended in this direction. It's different from the regular logging facilities that CockroachDB has, in the sense that the event log provides structured events. Structures means that the different parts of an event can be decomposed and analyzed separately. For example, a grant statement for granting some privileges to a user on a SQL table would have 4 different fields of interest, possibly more, but at least it would have the user that initiates the commands, the user that is the target or the the person who benefits from the grant, then the privilege being granted, and the object on which the privilege is granted. And structure, because they will be in different fields, and there are different field meanings that later on we can extract those fields individually and reliably. In contrast, the regular logging facility has a facility that only prints text, and so any information is flattened into a text message, a message string that is in structure opaque, and therefore we don't provide any guarantees about whether information can be extracted from it using, for example, event parsing. So the project here is to modernize and productionize the event log. So the event log, while being a system that is extremely old in the history of CockroachDB and to some extent largely stable, it has never been productionized. What that means is that the code is so organized that it is very brittle, it's very easy to modify it and create changes that were backward incompatible without too much guardrails. And it's also very interestingly extremely inconsistent. Events that should be related to each other and contain similar information, in fact, do not. An example of this would be that there is a field that should identify the SQL server that is initiating an event, because a cluster might have multiple SQL servers side by side. And that field is only populated for less than 1/3 of the different events. And the reason why this mistake exists is because the code that is doing this initialization is repeated over and over in more than 2,000 places in the code base. And every time someone adds an event, they might forget about these things. And because we don't actually check it, that means that we don't eventually have any guarantees that is going to be consistent. So here we are. This is a project that is probably going to spend maybe more than just one session on this live stream. And we are going to see how much we can complete today. There is some initial work already from a few experimentations I ran a few days ago. So I will first start by showing an example location in the source space where event logging is being used. So for example, we can go at drop database. Let me make this slightly bigger. And we see here an example call. So what we're seeing here is the event logger struct is reconstructed dynamically on the spot at the end of a drop database operation. And then its method insert event record is called. This method takes as arguments as the fields, the payload, if you will, for the event log record. So let me rebuild this so that we get rid of the linter messages. And the fields include currently a string that describes the event type, then some items of metadata, in this case, say identifier of the database descriptor and the identifier for the SQL server, and then a structure containing the structured elements of the event. And this is, in this particular case, composed by, say, database name, a copy of the SQL statement that was entered to perform the operation, the username of the user who initiated the operation, and a list of objects in the schema that have been dropped as a side effect of dropping the database. That's possible because in SQL we can use drop database cascade, and that will cascade the drop to other objects. An example of the outcome of this would be observed in the system.eventlog table. So we are going to have a look at this. I create a database, I drop it, and then we look at the system.eventlog table, its contents. So what we see is the last two events, create database is here, and then drop database is here. So there are other columns in this event log table, but these are the payloads that our code that we just looked at were about. And so we see here the identifiers. So what this last column is about, I actually don't know, but we are going to investigate. So we have an info and a unique ID. So the unique ID is a event ID and it's generated using UID function. So it's actually a random value we are seeing here. And it is represented as a byte array and not using the UID type. That actually arguably is a problem, but I don't want to solve this problem right now. Oh, hi, large data bank. Hi, Jordan. Nice to see you here. Say example of if there were tables in the database would come like this. Oh, I don't know how to write SQL. Let's try again. There we go. Right. And now we look here at our statement with a drop, and we see that the schema object d.public.t has been dropped together with the database. Just looking at this makes me think that we might even have a bug here, having a object ID containing periods, but without the quoting inside is likely not correct. So let's verify this. Let's make a table that has special characters in its name, and now look at what is happening here. Oh, so the name has been quoted properly. This is awesome. I am positively surprised, but also relieved. And I'm also going to turn on the lights because it's very dark here. There we go. Cool. So here we had an example event of how this event gets generated. And what we see if we look at this insert event records method is that it is called in many places. So there are 45 references, probably one of them is a test. And then we have different kinds of tests, and every of these call sites has a different argument list, and the data structures are defined at the call site. There is no restriction that prevents a developer from adding or removing a field, renaming a field, changing the way that the fields are populated, and in particular, forgetting or improperly filling the numeric argument for the shared metadata. So that's kind of annoying. So what we are going to do instead is see if we can make this an API with stable message types for, say, event logs. Event logging events, the log events. So for this, I started to express a new package called event.pb containing data structures for our various log events. And the way we started doing this is to factor a number of the fields that are shared by the different log events, and then defining protobuf messages for each of the individual events that we are interested in by reusing the common payloads every time, so that the surrounding code will be able to populate them consistently. And so we see here events for all the different cases that are in the list of referrers for the insert event records. And in one case, I even went forwards and made the separation. We had, before this work here, a single event log message type for all the privilege grant and revoke operations, regardless of whether they were granting privileges on a database, a table, or a type. And also regardless of whether they were grant or revoke operation. And now I have expanded this event type into many different fine-grained different logging event types that each cover a different part of the semantics of grant and revoke. It is possible that we will want to change the structure further in the future. That is just natural. The moment where we start to provide this structure with comment fields, it's very likely that the users will start to understand that they can expect more from this and desire more different events and maybe more fields to describe the operations. So we can probably look into this as extensions later. Now, for the benefit of people who are going to come to the stream a bit late, I'm going to take the URL for this and add it to my tmax profile at the bottom of the screen. So that is like this, set g status right. Maybe I can paste this entire link, probably. And then I can paste the remainder, which is my system load information. Oh, I was a bit optimistic. So let's shorten this URL. That's better. So now the Cockroach issue number is here at the bottom of the screen, and we have a reminder for the remainder of the session. All right, so we have these different message types, and I have tweaked the build rules so that they get structures like the processed by the protobuf compiler. And I see here all the different event types that I have defined earlier being generated as a struct. So we're happy about that. I created a sort of test here just to verify that the JSON structure of one of the event was compatible with the shape of the event we had previously, event PB. I'm not necessarily going to keep this test file in the future, but let's see. So we have now data structures, and we have those call sites throughout the remainder of the code base. We need to create an API in between and then gradually introduce usage of our new API throughout the remainder of the code base. So we are going to have a little to-do list for today. So create API to instantiate fill in, say, common fields for every event. Then connect the API to the server. And then we are going to demonstrate the API with at least 1 or 2 event calls. Connect the API to the existing system.eventlog table. And then as a stretch goal, we can say convert more API calls to the new API. There is another part of this project which is not going to be today, but that we should be thinking about. Now we have a protobuf definitions here. That is now a file that can be analyzed automatically, and that means that we can create a doc generator to automatically document all the event log event types. That is a feature that has been requested by customers for a very long time. And so we sincerely hope to be able to provide this in the next release. It's not been budgeted, but who knows? Who knows? Once a protobuf is in the picture, certain documentation projects become much more tractable. So what do we have here? The common fields are a timestamp, the user who requested the operation, the node ID for the server where the operation is taking place, and the instance ID is the SQL Server ID where the event also was originated. So this is a new field that we didn't have in previous versions that is related to the multi-tenant infrastructure that is being introduced for Cockroach Cloud. And that is an example field that is currently not being consistently populated throughout the code base. So we will want to fix that. All right. So we need an API that adds details to the payloads. And then we have for SQL events a copy of the SQL statement and a copy of the descriptor where the operation is taking place. All right. Let's see how the event log source code looks like now. Today, the event log has all these event types that are identified using strings. It's possible that we will want to keep those strings to identify the events in the event log data structures in the protobuf format, but that is okay because the names of the events that we chose in the protobuf file can be derived into strings. And so all these big tables that have been maintained by hand until now can probably now be automatically generated as well. So we are going to look to that later. So an event logger takes the executor config, and then the insert event record takes a transaction, some event log type, then target ID, reporting ID, which are the strange fields that are not being reported reliably now, and then the opaque payload. So what we want is to do some typing here, some strong typing. So we want all the payloads we have here to implement a common interface. So this is something that I can probably implement a code generator for using protobuf compiler, but I will, for this particular case, invoke the power of Perl instead, or sed possibly even. How do I do this? We have here a file where all the messages have been identified by the first line starting with message. And so I can extract all the message types, and then I can actually even use the power of Oak instead of Perl by saying this. How do you concatenate strings? Probably like this. Better. Off we go. Off we go. And did I, yeah, they look about right. Should have a comment or be unexported. Oh, so the thing wants me to have comments everywhere. Oh well, let's do this. Event payload implements the event payload interface. There we go. Now we have an interface that will allow us to enforce that only types that implement this interface can be passed to our new API. All right. So what we want is a way to prepare these payloads inside SQL code. So hypothetically, I'm going to start by instantiating something by hand, and bit by bit we're going to take bits out into a different place in the source code. So in this case, I would say event pb dot drop database. And so we have the common what is the common fields? Let's see. Common event details. Then there will be a common SQL event details. Oh. Yeah. And then there will be a database name. And the database name is n.n.name.string. And then here we will have a statement. And that is n.n.string. And then we have the common node details. Oh, common SQL event details. A descriptor ID. It is a db-get-id. And then we have instance ID. It's the extended sequence ID, node ID. And then the user. And what are we missing? The timestamp. Is it time.time? So it's going to be something like this. So the instance ID should be in 2. Probably could have this implemented using a proper oh, node ID is not a thing anymore in SQL. SQL servers don't have a node ID. In fact, that is interesting. So within the multi-tenant infrastructure, we don't use node IDs anymore. We use instance IDs. And that means that in some cases the node ID cannot be populated. All right, so there is some finding here. So one finding we can add to the issue here. SQL level log events operate within the context of a SQL tenant server, which only have a SQL instance ID. Say, these do not typically have access to a node ID, which is a KV concept. Cluster level log events do have node IDs, but they don't typically have access to a SQL instance ID. So we will need different metadata for some. So that's a new insight. So the new insight tells me that actually it was a mistake to have the node ID and the instance ID in the common event details, because they actually do not overlap. And the user account doesn't seem to be right either. So we're going to take those fields out of the common event details and add what is missing here. So SQL has a user account and it has an instance ID. And then it also has a descriptor ID. And then we have node restarts and node join events. Node event details. These will have a node ID. And then we're going to look at those fields a bit later when we look at node events. So, common event details, we only have a timestamp here. The node ID doesn't exist for SQL event, and user and instance ID are actually fields for SQL. So let's try to refresh our protobuf definitions. Okay. So arguably here, this data structure contains at least the same data. No, it doesn't actually. Database name, it's a drop database. So I have a dropped schema objects in that event. Right? Dropped schema objects, yes. All right, so now this event contains the same data as the original one. So let's try that out. So if this makes progress and brings us closer to our goal, meaning that I'm now able to use these data structures instead of the original data structure, and I get the data I want, that means that we already have one step forward, that we can standardize all these data structures. So standardization is achieving one of the goals, namely step 1 and step 2. So if we were able to do just this, and if we did not automate the consistency of the filling, we would already be in a better place, because having those fields like this would mandate that they are all being filled. So that's that. Let's see how it goes. All right. We see here two things of interest. That is fascinating. Fascinating. So we see that our event log has worked, that our new event type, our new log event type is now reported in the system.eventlog table properly. What is different though, and that is very surprising, is that the field names for the JSON payload are now in small letters, whereas they were in capital letters previously. That means that the serialization algorithm that is used for transforming the event records from a struct into JSON is using a different logic now than it used to have before. So how was this being done? So we were using JSON.marshall here from the encoding thing. And so this was in fact running JSON. And that means that the reason why it's not overlapping is because probably protobuf has forced the field names to be small letters. So we need to confirm this. Let's see. JSON type struct. Let's ignore errors because I trust that it is going to be fine. Yes, so that's what it is. So JSON by default respects the casing of the fields in the struct, whereas protobuf, the protobuf compiler, has generated JSON field names that were in lowercase. And that is why we see a difference here. The database name here is in lowercase. So, all right, our JSON payloads have now different casing and different field names. Is that an issue though? I don't know. Maybe it is, maybe it's not. So I'm going to take this into the to-do file and add a new section and insert questions where it will need to be input. Important to keep the same casing for the JSON field names, previously same as the struct, which brought above become to preserve the casing. All right. I will at this time consider it's okay because we did not make promises about the particular shape of the events in the past. But changing this to have specific field names is not super complicated, so if it becomes important, we can always adjust this later. Besides, otherwise, the fields get filled properly. What I'm missing though is the timestamp and the other fields. Okay, that is actually very strange. So it probably has to do here with the fact that JSON here is empty. And so it's possible that having this empty is not what I had meant. Maybe it needs to be with a minus. I don't remember. Don't remember how the JSON tag work. So let's see how this makes progress if I add a minus here. Doesn't help. Doesn't help. So here we have a particularly interesting and annoying problem, which is that we have here a event log struct where I had wanted to be a bit more clever. JSON tag. What about having this inline? Oh, so the user did get printed properly. Oh. The user in the previous iterations, did the user get? Yes, the user was printed properly. The statement as well. So actually, it seems that it was working properly. So only the common event details had an issue. Oh, interesting. The timestamp is being populated, isn't it? And then these. Is it possible that only one of the embedded fields gets dumped in the JSON output? We can check this here actually. No, they get all dumped together. I'm getting spam on the chat. Let's see. All right, so I get the user and the statement. And I get this, but I don't get the additional fields. And they are here. I didn't also see the instance ID. Oh. I think that I was being silly here. If the JSON tag is being eliminated with this minus sign here, then of course I'm not expecting it in the output. Silly me. So what's going on here? Okay, so this needs a little bit of an explanation. So the source code here explicitly defines the JSON tag to be minus, which means disable this field from JSON output. And because the fields are disabled, that is exactly the reason why we don't see them here. So what is going on here? The truth is, initially, these different structs that are defined in this file, I started exploring with hypothetical goal to preserve the same JSON structures that was already being used in the past, as is, with this possibly misguided idea that there shouldn't be more information with the new system I'm proposing than there was before. But in fact, that is actually not exactly reasonable, because applications that manipulate JSON are completely fine with having fields, extra fields, because typically they only look at the fields that interest them. The other problem we saw is the fact that the fields have a different casing in their name is actually more important than the insertion of additional fields that were not there before. So I would probably want to care about that more and stop unreasonably caring about the apparition of new fields that were not there before. Let's have all the fields. It's also going to make debugging easier and more clear. Here we go. We have a timestamp. And then the statement, the user, the instance IDs, the descriptor IDs, database, and the drop schema objects. So all is there. And now we see here redundant information between the payload and the other fields. What we're going to do is the following. We're going to verify that they are marked to be omitted if they are set to defaults. Not so we're going to do gogo proto.json tag omit empty. I think. What I'm trying to reach here is a situation where the field is omitted if it has its default value, 0 value. And this way we can reduce the redundancy with the remainder of the system table. Oopsie. So our timestamp field is, oh, look at this. And now we get the cases. So, okay, in this case, at least I know how to restore the casing to the original shape, should we want to have that eventually. But the reason why I care about this is because of the following. Now we're going to take, say, event in the drop database, sorry, event log. And then we are going to say now, oh, now it's the transaction timestamp. Wow, that is interesting. So what I wanted to do is the following. It's a test. The idea of this, if it's successful, we want to see the timestamp disappear from the struct when inserted into the system table. And the reason why this would work is because the field is marked as omitted if empty. And so if we erase it with the default value, then it's going to appear empty to the JSON encoder. And then it's going to disappear, hopefully disappear from the JSON serialization. Did not succeed. So why did it not succeed? Oh, the event is passed by value and we have a cast by address. This is not a success yet. We will see, okay, we will need to work on this a little bit. Maybe it's not a big deal. Maybe it's not a big deal. We'll see. Okay, so let's inventory the next step. So what we want is to look at the point of call here and then take the construction of this big struct here and then move that to a helper function that is going to factor the common steps. So the generation of a timestamp, the copying of the current statement and so on. All this should be done in a central place because it's going to be always the same nearly for all the statements and all the SQL logical plan nodes. And because of this, we can write this code just once and then have it used everywhere in SQL where events are being generated. And the only thing that is going to remain different is going to be populating the individual fields here. So it's going to be less error prone. So that's what we're going to do next. However, I'm seeing that we have been at this for already 1 hour nearly. And we should never be sitting at a computer for more than 1 hour in a row. So this is the time for the break, and we are going to see each other again in a few minutes. Enjoy the break and stay tuned. Hello again, everyone. Where were we? So we have this logic. And we want this logic to populate the fields for us. So arguably, an event logger can get a lot of its information from the SQL Planner, I think. Planner has the extended eval context, I think. It has a transaction and it has the extended eval context here. So we can capture the SQL instance ID, the user, the current statement, the original SQL, is there. So the planner gives us everything we want. The planner gives us everything we want. So it takes this event log here and we say that next to event logger we have here a new thing. Right. How does the built-in function for the now function in SQL work? I don't remember. Takes them timestamp. Okay. How does it get initialized? All right. Is the transaction a read timestamp? So all this is available in our function here. So we have a timestamp. It's going to be p dot extended ctx dot xen timestamp. All right. It's going to be p dot extended let's see, where is that coming from? Eval ctx dot exec cfg dot node id for instance id. Then we have the user. Then we have the statement. Statements equal. Where did we find the current statement? I think we had it. We were looking at it just earlier. STMT. And we want statement AST. Right? I don't remember statement dot AST dot AST dot string, and then there will be a descriptor ID. And what is the type of that? That's pb.id. And now we can do some magic. And the magic is so this will return an error, and we're going to do a return make event logger of p dot extended ctx dot exec cfg dot insert event record p dot xn, and then we're going to have event pb get event name of the info, and then the event ID we have say instance ID we already have, and then say event is here, and we are going to populate the missing fields. Event pb command and then we have this one, event with command SQL payload, same story. And then we have those things here. Oh, the instance ID is a sign in 32. Interesting. In 32, there we go. All right, so what's going on here is that we are going to compute the common fields from data already known to the planner. Then inject the common fields into the payload provided by the caller. And then delegate the storing of the event to the regular event logic. And now we are going to replace the call that we had here by p.eventlog or log event, I think, log event. And then it's going to be setx, and then nothing else except for our drop database event. And we only care about the fields that cannot be computed by the logging function. That gets returned. And now all the complexity that was there before is replaced by a function that is going to be generally much simpler. All right. There are a couple of functions we're using here that are not yet defined, namely the event with common payload, common SQL payload, and so on. These are interfaces that will give us access to the fields inside the new protobuf types we have defined. This is because Go doesn't support casting a derived type to one of its embedded types, and so we need to have methods that give access to those things. And so we are going to take our field here and say type event with common payload, and then payload gives us access to details, common event details. Maybe we want to call them details here. So Go likes when we use the same receiver variable name, and so it needs to be an M here. Common SQL payload, SQL event details. There we go. Now we try to compile this. Common SQL details. SQL common here. And then get event, and define info event. And now we need a name generator for our event types. And so here we are going to use the power of set and Perl and these kind of things again. Okay. So we extract the message names. Then we get the second word, and then we convert from camel case to snake case. And how do we do this? We do this like this. Like this. Like this. Like this. And that is not too bad, but that's not exactly what I wanted, right? Because I also want to have the original name next to it. So I'm going to call this last one, and then I have list 2. I think I can join the thing side by side with a command called join. And how do I do this? Paste. Maybe I need paste, actually. Yeah. That is better. Okay. All right. So I'm going to paste this. And we want to have a mapping between the two. And so we do this like this. Printf. And so we want a quote, colon, actually go on reflect. Type of, that sounds right. Reflect type of, this is to be like this, colon, and then this, comma, $1, $2, and with a new line at the end. So we're mapping all the individual types to event name that is more or less similar to what we had in the past. So event names.go. And so package event pb, and then var event names map for the type string. There are a little bit of oddities like this. All these common things go away, and that's better. And so we need to have here a event name retrieves the name, say system.eventlog type name for say given payload. Right. And the function we had in event log was get event name. So let's see what it says. Why my Go import is not able to find it is magically unknown to me. As type event log type. I appreciate you telling this to me. All right, we can now try this. Directory. Our drop database event is populated with the right name here, with no right name, with fields here. And then we have a timestamp. Oh, it's because I still have this erasure here. This permanent can go away. That will restore statement. The statement is populated properly. The user is populated properly. Instance ID, descriptor ID is fine. Drop schema objects are also fine. So we are still completely fine. And so we went, if we look at our diff for today, we went in drop_database from codes that would spell out in the site of the call all the parameter for the event to code that calls a single method on the planner that will capture all this information automatically and consistently. And this way now I can go to another file, create database, for example. I can look at the ways the event log is populated for a create database event, and I can replace this by this params.p.log event. Then the descriptor ID, and then event pb.create database. Database name is name.string, and that's all. Everything else is derived automatically, and there was much rejoicing because now our logging has become standardized and there is much less of a chance for mistakes to be made. And so I think that what we have now in our to-do list has made a lot of progress. So create, this is done. Connect the API server, we've done this. We have connection here, and then we just demonstrated with two, create and drop database. And well, it's been over time already, so I could go and modify more. So rename database. Same story here. Let's take the other one and copy paste the code. Drop database. And then it's going to be rename database. And then we will have a new name. And that was it. Now, we are going to have standardized, auto-documented, stable, uniform, consistent event entries for our database activities in CockroachDB, thanks to this new infrastructure. And so I will, off camera, go through the remaining API calls and do them all one by one to ensure that all of them have the data. And then either off camera or maybe next time, we are going to look at the doc generator. I will also go to coworkers and ask this question: do we care about the casing for the JSON field names? If they say, yes, we do care about the casings, then we know how to do this. It's a matter of adding JSON tag annotation, the protobuf source file that will change the name of the fields to what they were originally. And then we will have just more or less the same behavior as I was there before. So that was it. If we go back to the issue that we were working on, then the step one is more or less achieved thanks to this protobuf definition file. Then the population of the fields we have factored into a single function for all the SQL package. So that will serve for all the SQL events, which are all of them except for 3. Then we are still need to do the step 3, that is going to be for the next session, and 4 as well. So we have achieved step 1 and 3 of this issue today. And it's pretty good. More or less what we had planned. Everything that was in the to-do list is done. And we now have standardized events. And let's see if the experiment is keeping the timestamp properly. I think it is. Yep, timestamp is here. And what we just did also is to populate the timestamp from the transaction timestamp, meaning that now we should see a similar timestamp here and here. Do we? Looks like it. Not exactly, actually. Well, this needs to be investigated further. We'll see. It's not a big deal. We'll see that later. Anyway, so thank you for watching. Thank you for being here and accompanying this experiment. And hopefully we will be able to complete this project before Christmas. So thank you again, and have an absolutely great day. See you later.